Now, as far as the tips and tricks go, we were searching for a building model that would have the three-dimensional facades of each of the four faces of the building. We did have some trees, and so we are on the north side looking down, and as we cycle through the flight plan, there were two elevations. One was at 175 feet. Here we are at 175 feet. The idea with two elevations is the gimbal was focused at a 63-degree angle at the higher elevation and a 47-degree angle at the lower elevation. So it made two loops around, which provided for some great panorama shots. But what's nice about this is after you take in the point cloud data, you can replace this facade with a digital still image and then have that material applied in a georeferenced and scaled rotated facade, because ultimately this job is going into Revit. And so this is one of the workflow processes on a collaboration for Revit that we're looking at the photos and trying to establish some best practices. We'll call them standard procedures on actually using the data. So there's not the same albedo effect that you get with concrete. It is a brightness that is a too high of a reflectivity, and so shooting the site in a low light cloud cover condition actually gives you better surface data. So yes, the pictures are a little bit more grainy because of the white balance, but there is no reason that we could not just measure and find out the exact aspects of the orthomosaic once all the pictures get stitched together. So we wanted to know, if we wanted to know the length of the handicap ramp itself, we can always go into measure, quick distance from the curb, double click on there, creates an object over here on the right hand side that tells you that it is a distance. When you click on it, it is 14.06 feet. Spec is 14 feet, so we meet or exceed the requirements for develop. So we could do some parking stripe counting and different aspects. What's nice about that too is once we make the measurements, remember on the share function is that when you share a map, once you copy it to the clipboard and open up a brand new, and again I tried this, I'm not the best at manipulating. I'm going to just hit smaller size on this. I am not necessarily a Google Chrome guy, but this is another browser tab. I'm going to Control V paste that particular image, and so now you're seeing you can actually take and embed this as a hyperlink, and the measurements that we've made, both that distance measurement right here on the parking stripe, is available to any of your shareholders. Here's without the ortho. There's what you would get on a Bing map stream. But also, once you click on the individual volume, it is 12,366 square feet. And notice that you're also getting, of all things, the cuts and fill volume. We have a cut volume of 7,442 cubic yards. Now, where does that come from? Let's look at the metadata applied to the LAS file that was created. The volume is, I'm going to turn the photos off at this point. The volume is actually a measurement here. It calculates, we got 12,036 feet. I'm going to just see if I can bring this down for you. This was nothing more than a polygon that was created. You can change it, but then you actually say view the volume in 3D. Now this, understand, this was the first flight that this particular operator had been training on. So I want to demonstrate the ease of use. This is being a panorama flight, you still get the surface data. But the terrain will actually come with it. But what we want to do is we want to give recap the input parameters to actually create the highest quality 3D mesh with the base plane that it can. Obviously, there are 4 different ways to do the base plane. You can do the whole lowest elevation, the highest elevation. But when you're looking at this individual base plane, I want to make sure that you understand the concept of the base plane itself. Now, as we're looking at it here, I'm actually panning and zooming around. I'm in the mesh itself. If I turn off the base plane, which is the brown, and the mesh, it gives me the ability to look at that data in three-dimensional view. And here I am on top of the roof. And let's just follow this through. Now, on the elevation data itself, there is a mesh that gets created. But I tell you one thing, if you were to fly this in purely a planimetric mode, you wouldn't get the 6-foot wooden fence that appears right back here, or rather, let me say, in this particular photo, we're going to be able to see that there is a perimeter fence. And the trees themselves can be cropped out. Once you see these three-dimensional planes, this is the side of the building here, and it actually says I don't have elevation data. And so this particular model will allow you to bring in a recap mesh file or an RCS, a cloud file, to actually pull out some of the extra noise using the building corners and knowing that you've got now a three-dimensional model. That was a result. Not because of the quality of the sensor, which is the highest. Know that Sony is actually giving you the best RGB output because these are digital still images, but being able to calculate some of the volumes and come up with contours is an instant process. So let's talk about some of the metrics on this job. Flight time. We set up on the site. We're standing right over here. Here's the ortho mosaic. We spent 5 minutes mission planning on a situational awareness. Then we put the drone up in the air. It went and took 72 images here in the photos, flying 2 elevations. Each one took 4.5 minutes. So you're looking at a 9-minute flight to get an entire 3D model at that point. When we would maybe want to use contour data, let's go to a 1-foot contour and say, in this spot, let's actually use the contours for the site. Now, what does that mean? Well, it's actually going to contour up the side of the building. We can pull those out. But it's also going to contour the site itself. When you're at 175 feet and the gimbal is focused at a 60-degree angle of incidence, then you will get both the building model, the roof, and the site plan. And that's the beauty of the panorama feature. And so if we wanted to bring in a job, we could actually merge into a grid mission that we flew from previous jobs. We could compare 2 grid missions that we flew and see if there's a difference in the volumetrics, if any earth has been moved. But obviously that's silly in this case because we are on an impervious surface. So now what we do is we get into the point where we want to then export this for our building information collaboration. Now remember, the share also gives you the ability to share the photos. By hitting download, you'll have a zip file of all 72 of the photos in RGB format that you can use for a multitude of purposes. What I do is I bring those into another piece of software, and I make sure that that software is producing the quality data. One of the best sharing is to take those photos and then use them as an exhibit. You could process 4 of the photos. So if you had an ADA issue, if you had a sidewalk issue, or a cadastral issue, that's a generator, there's a trash dumpster back here. If there was an issue, you could process just a few photos themselves and still come up with some 3D models of infrastructure for sure. Now, when we export, this button right here gives you the ability to export in a number of formats. As we go through, I start with the processing report because that gives you the quality of the camera data, truly the photogrammetric end of it. We look at the Pix4D and we realize, wow, here's our terrain surface model. If you're doing surfaces in Civil 3D, that digital surface model contains by far the most important information for the analysis of the surface terrain as you're defining it. We fly around in here. Green is good. Look at that. We got totally Pix4D overlap. Now, as we look at overlap and maybe the absolute camera position uncertainties, just a reminder of my favorite buttons in the Pix4D report. This I button here throws you out onto the web where you can actually look at all of the quality report parameters and it says on your overlap, this is what it means. And as you go down and you see a hyperlink, it says, okay, when the 3D computed point and you're looking at your block adjustments, it says for more information. I love the Wikipedia aspect. By far, the best knowledge base for any software that I've seen over the past 20 years. Pix4D has intuitively anticipated the questions and set together a fully linked Wikipedia of the basically how-tos and what to look for, even if you're just troubleshooting or if you're looking for best practices. And so just know that when you're bringing this in, there are videos, webinars, audio tutorials, there are PDFs that you can bring down, and you can also then just hit follow right here, and it will follow the Pix4D support. So shout out to Pix4D, the second best support on the planet. Number one, and this should be a drum roll, number one goes to the folks at 3DR. Just the simple contact support. I got to let you know, I'm on the phone probably every other day with these guys. We're doing some beta testing, some research and development that is allowing for new developments to come out. And the responsiveness, the attention to detail, the aspect that they do not give up until they know, they don't hang up the phone until they know that you've got all of your questions answered. So that combination between the 3DR and the Pix4D support, coupled with the sensor from Sony, the intuitive and best practices, we're talking best-in-class workflow that Autodesk has provided. You're dealing with a collaborative team where this ought to be the Harlem Globetrotters of photogrammetry. We just make it look easy. Now here at ATG, our job is to convince you of the solutions and to provide a system integration for whatever sensor you happen to be using. We just want to highlight and to communicate to you in a non-technical basis, more on a workflow basis, of the opportunities you have to use our team augmentation, to be able to use the sensors, the data, the workflow on whatever project comes your way. And so stay tuned. Our next webinar will be actually focused on the difference between the LAS clouds and the recap clouds. What's the difference between the OBJ mesh, if you're going into like a sketch fab from an object modeling, versus the RCM 3D mesh, but what to get out for. What we don't want is we don't want a mesh that looks like some tablecloth that's been thrown over the job site and it has no meaning on any component whatsoever. A break line less, what it ends up being is a Poissian surface without any intelligence on grade breaks whatsoever. So we want to avoid you using those to create your contours, or worse, just taking the contours themselves from the site itself, like right here, and using these contours, which is a tree, by the way. You can kick out a PDF of the contours. You can realize that the contours go up here, and you can't count the number of contours that it takes to get up to your 32 foot on the top of the building. But you can see that contour was created from a water spot on the asphalt. And so that may actually be the elevation, but I tell you one thing, it surely isn't a grade break, and that spot on the parking is the same as this spot as far as elevation goes. So don't be fooled when you contour in a vehicle as a surface object or use these contours for development without fully understanding the metadata and the point groups and the precisions and accuracies from a fully geomatics perspective. So yes, it's a feature, and we don't want you to forget that. Yeah, you can throw a contour map out, but what it is, what it looks like, and what it means are three entirely different things. So what we're asking is that you allow ATG to be part of your next project, either in a purchase of one of our sensors, service contracts, the training aspects, team augmentation, allowing us to come out and do the work. Whatever your choice is, know that you're going to get the straight up and the best practices. Contact me. It's a real simple email address. It's Tom Eckert. I'm a CST. The email address is teckert@atgusa.com. That's T as in Tom, and it's Echo Charlie Kilo, Echo Romeo Tango at ATGusa.com. We sure appreciate you watching, and congratulations to our initiated first go-round of our FAA training that we were doing here at our North Little Rock office. Hit ATG up, call one of our sales guys, and let's get a quote in your hands, as even if it's just a feasibility study, that we can prove to you what the future of making things really looks like, what decisions can go in to allowing you the efficiencies to be profitable, on time, under budget, and most of all, ready to slap a high five, because through the life cycle of the project, you provided value engineering through the entire construction phase, from design to keys to certificate of occupancy. Thanks for watching. This is Tom, and have a great evening.